Hey everyone, thank you all for coming today. So today we're going to discuss SageMaker and to see some real-world attack scenarios. I have a very special guest here today, my dad and my grandfather. They came all the way from Israel, yeah. My grandfather is 82 years old and he flew all the way here. Yeah, so I really appreciate it and I'm very excited about that. So if someone has a job offer for them, they would love to. And yeah, before we start, let me introduce myself. My name is Shani Peled. I'm a senior cloud security researcher at Sentinel-1. I started my career in the Israeli Intelligence Corps as a cyber defender. And then right after my release, I joined an Israeli red team company where I worked for 4 years. I attacked Fortune 500 companies all over the globe. And then 8 months ago, I moved to Sentinel-1. Now I'm part of the cloud security research team there. My main focus is on offensive cloud and AI research. And yeah, that's it. So feel free to connect me. And now that you know who I am, I think that we can jump into what we're going to cover today. So first, we will do a quick brief on what SageMaker is for the one who are not familiar with it. Then we will discuss the quick setup mode. We will discuss what happens when you use it and why that matters for security. Then comes the spicy part of the talk. We will walk through 4 real attack scenarios. We will start with the simple ones. We will continue with the more advanced ones. Then we will see a short tool demo of a tool that I wrote. It basically checks what resources your SageMaker role can access and shows possible attack paths in your own SageMaker AI environment. And then we will have some conclusions and recommendations. You don't need to worry if you're new to SageMaker or to AI. I'll try to keep it clear and easy to follow. So, AWS SageMaker is a cloud service that makes it easy to build, train, and deploy machine learning models. You can think of it like a managed lab where, in the cloud where you can do experiments with AI without worrying about setting up servers or software because AWS does basically everything for you behind the scene. Jupyter Notebook is an interactive environment where you can write and run code and get the results immediately. It's especially popular in data scientists and machine learning engineers. And Jupyter Cell is a small block inside the Jupyter Notebook where you can write and run pieces of code. So the first thing I did when I started my SageMaker research was to create my own environment. Then I noticed that I have 2 options. The first one was the quick setup mode. Very fast, 1 click, everything is created for you automatically. The second thing was the manual setup, where you have to create your own VPC, IAM rules, and many more configurations manually. Now, being honest, like most of us, I decided to choose the quick setup mode. Like, if AWS is offering a big shiny button that says, set it up for me, who is going to say no for that? But as we will all see soon, the easy button also hides some interesting security risks behind the scene. So I created my SageMaker environment, and that's how it looks like. I totally understand why it's so popular. It's very, very easy to use, very approachable. And then I started to explore what is going on behind the scenes. Because I just used the quick setup button and that's it. Everything was created for me. So of course it hides some things behind. And as you can see here, I saw 2 interesting things. The first thing is the default execution role. You can see that the role has a specific convention. It's called Amazon SageMaker execution role, and then you have the timestamp of the date and time when you created the domain. The second thing is the network configuration. You can see here the network mode, which is public internet access. It means that from this SageMaker domain, I'm able to access the internet without any restriction. Then I entered my Jupyter notebook, and the first command that I've executed was the very common one, I believe that most of you are familiar with. And I saw that my context is the user, the default user that was created while I created the SageMaker AI environment. And that's how I started my research. That was the starting position. So I started to explore and to try to understand what policies are attached to this default role. And I discovered that multiple policies are attached to it by default. And of course, it's very interesting for researchers and red teamers to start to explore it because it's very, very permissive, and we will see it in a moment. So, as you can see here, I discovered multiple permissions. You can see glue permissions, S3 permissions, SecretsManager's permissions, like it was all over the place. And I tried to start and understand what can I build from it. And long story short, if we will jump to the end, I discovered multiple attack scenarios and that you can exploit from Jupyter Notebook. So you can take a picture of it. You can also scan the QR code. It will open you the full blog and POC. Of course, we are limited in time, so we will not explore everything, but I will show you some of these. If you want to see the full detailed POC, you can access the blog. So, the first attack scenario that we're going to discuss is cross-domain secrets access. It's a very straightforward and simple one. It's even funny how simple it is. So, before we start, I will explain what SageMaker domain is. SageMaker domain is an environment that manages users, apps, authentication, and shared settings for SageMaker AI. Basically, each user gets a profile and isolated storage, all under the domain security and network configuration. It's basically a logical unit of SageMaker environment. For example, each AI team can have his own SageMaker domain. It's very comfortable, very easy to use. And what I discovered from my perspective was that my user in SageMaker, the default user, has SecretsManager list secrets on every resource. It means that I was able to basically enumerate all secrets from my Jupyter notebook. But it wasn't enough because I also want to get the secrets. I'm greedy. So I discovered two interesting things. I saw in the policy that I can describe, get, and create secrets that have both either starting with Amazon SageMaker in the key name, or has the SageMaker true resource tag. Then I started to perform secret enumeration from within my Jupyter notebook. As you can see here, I can see all secrets, and as a result, as you know, when we are doing list, we can also see the metadata of the object. So basically, I could understand what secrets I can read, because I could see the tags and the names of the secrets. And as you can see here, it was very easy, very straightforward. I could get the value of secret from another domain without any restriction. It means that we start to understand now that the domains in SageMaker are kind of flat. It's just a logical thing, because I could access the secrets in a completely different domain with my default role. The next attack scenario is glue data poisoning using S3 permissions. So just a quick brief on AWS Glue. AWS Glue is a cloud service that helps you to move, clean, and organize data. For example, if you have raw data files stored in Amazon S3, AWS Glue will automatically read the files, clean the data, and makes it available and searchable in databases. It's very, very, very common. So I discovered multiple glue permissions. I started to think what I can do with it, how I can abuse it. And then I saw another interesting thing, and very severe one. I saw that when I created the domain, automatically this policy was created. You can see it with the same timestamp. And it was attached to the execution role automatically. And as you can see here, I have a very privileged S3 permissions. I could get, put, delete, and list buckets for all buckets in my account. So I started to think about the abuse, and I discovered that the combination between those will help me to basically create a data pollution. So I used the glue get database and get tables in order to enumerate and to understand what is the structure of the data. And then I used the S3 in order to download the data, to alter it, and to upload fake data to the data that basically the models are learning from. So as you can see here, first I started by S3 enumeration. You can see that I'm able to see all of the buckets in the account regardless of my SageMaker domain. I can also see even Terraform buckets. Then I started to download sensitive files. I downloaded files from that are related to another SageMaker domains. I downloaded Terraform files without any restriction. And then I started to do enumeration on the glue tables in order to understand what is the structure of the data. Then, as you can see here, I'm actually able to see the table metadata in order to understand the exact structure of the data that is used by the SageMaker models. Then I downloaded all of the data. In this case, it's real-time predictions. I deleted it because I'm evil. I created new real-time predictions exactly with the same structure, and then I uploaded it, and yeah, that was the second attack scenario. Again, it's very straightforward, and that's like how funny it is, because each one of you that is using SageMaker can abuse it. It's not like a specific CVE that is already blocked. It's like a day-to-day risk. So this is the second attack scenario of the glue data poisoning. And now we're jumping, like the next two attack scenarios will be a bit more advanced. And these are my favorite. So the next one is ECR and SageMaker backdoor deployment. A quick brief on ECR. Amazon ECR is a cloud service that stores container images. You can think of it like a private warehouse where you upload your image. So services like ECS or EKS can pull it and run the images. So, like almost every service in AWS, I discovered that my default role has also permissions to ECR. And I discovered a nice toxic combination of ECR and SageMaker permissions. First, I saw that I can create repository, ECR repository with any name that I want. And I also saw that I can put image to repositories that are containing the name SageMaker. So I could basically create a repository which is named like SageMaker 123, and then to push my malicious image there. Using the SageMaker permissions, I could create a malicious model that will use my malicious image, and then I could create endpoint that will execute this model, and basically to get a backdoor within the environment that will be externally from the notebook. It's a completely different endpoint. So as you can see here, I created a very simple reverse shell using sockets, and then I pushed my malicious image to my SageMaker repository that I've created. Then I created the SageMaker model, the malicious model that will use the malicious image, and I just created the SageMaker endpoint It's kind of like an EC2, but you can't look at it from the EC2 screen. It's like AWS manages it behind the scenes. And here, this is a screenshot from my C2 server in the internet. As you remember, we have default network access. So basically, I got the reverse shell from the new endpoint that I've created. And as you can see here, this is the attack scenario. We have list, read, and write ECR permissions. We can create SageMaker endpoint that will execute the malicious model, and we got a reverse shell to the internet, to our EC2 without any restriction. Last but not least, we have the last attack scenario, abusing Cognito IDP for privilege escalation. So Cognito IDP is a cloud service that manages user accounts, logins, and authentications for your apps. It's separate from your AWS IAM users. These are basically application users, not AWS users, but you can assign them IAM roles to control what AWS resources they can access once they log in. For example, if you have a web app that is managed in AWS and the user signs into your app, you can grant it temporary access to an S3 bucket by assume role. And this user doesn't have to be even a full AWS IAM user. It's an application user. So, I don't know why, I still don't know why, but the SageMaker default role has these very permissive permissions for Cognito IDP. And I used these two in order to perform my attack. So I started regularly by enumerating the Cognito IDP user pools and groups. As you can see here, like a good old red teamer, I targeted the IT admins group. You can see the role ARN, Cognito IT admin role, which is attached to the scope. It means when an app user will authenticate to the app in AWS, he will basically have this role, even though he is not an AWS IAM user. So I created a very simple script that will create my evil user and will add it to the relevant user pool. And as you can see here, the user was added to the group successfully. I authenticated to the IT app, and I got the JWT back. And if we will decode the JWT, you can see here the JWT of our evil user, and you can see that we got the AWS role, and basically we performed privilege escalation. So it's very important to understand that for every organization that is using Cognito AI and SageMaker in the same account, it puts the Cognito AI in an immediate risk. So this is the flow of the attack scenario. And here I created a nice summary for you. Of course, you have it in the blog as well, more in detail, but this is the summary of the attack scenarios and every permissions needed for them. And then I decided to go with it step forward, and I created a very nice tool that is called SageStrike. So SageStrike is a post-exploitation framework for AWS SageMaker IAM roles. Its purpose is to evaluate, abuse, and demonstrate real-world attack paths using the SageMaker IAM roles in your own environment. It means that after the talk, if you're using SageMaker AI, you can definitely use this tool to understand if you're vulnerable. The attack scenarios are built in TOML-based files. It means that you can add your own attack scenarios if you find ones, and of course let me know. I would be happy to hear about that. So let's jump into a quick demo now. Cool. So as you can see here, this is the notebook on the right, the Jupyter notebook, and I'm extracting the environment variables from it because we will use the tool from our endpoint. The tool is using the SageMaker identity. I'm just validating that I'm executing with it. Now we will start with enumerating permissions. Of course, we will not enumerate write permissions because we don't want to affect the environment. We will just enumerate read and get permissions. And as you can see here, we got the permissions that we have and we got the potential possible attack paths. Now we will start with listing secrets. These are the secrets that we have in the environment, and the tool is also indicating you which secrets will potentially be readable by SageMaker. And as you can see here, we are able to get part of them, the secrets from the other domain that we've discussed. Here you have the automated exploit of the Cognito IDP privilege escalation. You just need to choose the user pool, to choose the username, the email, and it creates it for you, and it also authenticates for you. And as you can see here, we will decode the JWT, and we successfully performed the attack, and now we have the privileged user. And the last thing is the backdoor. You just need to choose your evil model name and the endpoint name, and it creates it for you. And as you will see here now, it was created, and if you have, you can choose whatever you want, but if, for example, you've created the C2 channel, you will get the connection immediately. Okay, so now let's discuss a little bit about recommendations. First thing first is to follow the principle of least privileges. You should never assume that your AWS default roles are safe enough. Usually they're not, because they're often too broad or too powerful. You should give specific permissions as much as you can in your own environments. The second thing is to detect and fix default misconfigurations. Sometimes the easy default setups introduce major risks. Convenience is great for speed, but it can leave dangerous gaps if you don't fix the defaults afterwards. So it's important to keep it in mind. Third thing is to continuously monitor real-time activities. You cannot just set up notebooks and endpoints and forget about them. You need to remember that they are live, exposed components, and if they are compromised, attackers can use them for privilege escalation or data exfiltration, as we saw today. So real-time monitoring is critical in order to catch misuse early. And the last thing is to isolate AI from critical infrastructure. Notebooks and endpoints often look innocent, but they are not, as we saw today. So I will recommend to always separate your AI environment from your production infrastructure. And the bottom line that I want you to take from today is that AI is powerful, but it's also a new attack surface, and we have to treat it with the same level as we give to any critical system. Thank you very much. Here you have the QR code for the blog with the full POCs from today. You can also access the SageStrike repo and try it in your own environment. And of course, you can connect me. And that's it. Thank you very much. Do we have time for questions? Yeah, if someone has a question.